Hi, 10. So I had a request to do the question number 18 because there wasn't actually answers at the back of the textbook. So let's take a look at it. So the graph, right, shows us the path of a rocket fired from the deck of a barge in, right, and into Lake Ontario at the Canada Day. The barge is in Lake Ontario at a Canada Day fireworks display. It is a parabola where h is the height, okay, of the rocket and t is the time in seconds. So you'll see at this dot right here, right, it's not starting at 0, it's starting at this dot, which is at 0, 1.6, and it's going up into the air in the shape of a parabola and then coming back down and obviously falling into the water. So our first part A says, what is the maximum height reached by the rocket? Well, if we take a look, right, our maximum in this case is right here. And so the point is here 480, or we can look across and we can see that it's 80 meters. All right, so it's 80 meters because it's measured in meters, so don't ever forget your units. And we know that because it is the K value of the vertex. All right. So now it says, when did the rocket reach its maximum height? Well, every point has an x and a y, all right? So we know we're talking about the maximum height, so we know that we're talking about this point. So our y is height, and our x is time. So our x is telling us how long it took to reach the maximum. So if we take a look here, the when is this 4. So let me just so B is 4 seconds. So it took 4 seconds to get to that maximum height. And our when, because it's talking about the maximum, which is the vertex, then our when has to be the x value of the vertex or the h value of our vertex. So then it says, how high was the rocket above the water when it was set off? So let's take a look at that one. That one's C. So if we look, we see a dot right here. So we know that the rocket gets started, like when we set off the rocket, no time has passed. So we're looking at when our time is 0. So when our time is 0, we can see right here, it's told us that the height of the rocket was 1.6 meters. So the assumption is it was set off on the barge, not on the water, and the barge was 1.6 meters out above the water. So in this case, it's the y-intercept. Right, so usually when it asks you about a starting height, it often, especially when they're talking about time, is when our time is 0 seconds. So D says, find an equation to describe the flight of the rocket. So at this point, we need to figure out an equation. So we need to either, if you remember, we have 2 forms of the equation. We have vertex form, right, which we know is y equals a times x minus h squared plus k, or we have factored form, which is y equals a times x minus r and x minus t. So in order to do factored form, we need to know r and t. And r and t are x-intercepts, if you remember. And we don't actually know both x-intercepts. We know this one, but this one doesn't touch the x-axis. So we don't know where the x-intercept is. We'd actually have to extend the graph in order to be able to find it. So we're not going to use this one because we don't have enough information. Now, to use vertex form, right, we know that h and k is the vertex. And if we take a look at our parabola, well, we know the vertex and we know one other point. So we want to use vertex form. Okay, so I'm going to go over here and continue D. So I know that my H is the X value of the vertex, so my H is 4. I know that my K is the Y value of the vertex, so my K is 80. And I know that I need at least one other point, right? Because I have Y, A, X, H, and K. So I take a look, and I can either use the y-intercept here, or I could use the x-intercept of 8 and 0, right? Because I know that this is where it falls back into the water at 8 and 0. So what I'm going to do is, it's up to you which point you use, but you should get the same answer regardless of what point you use. So I'm going to go ahead and use the y-intercept. So I'm going to use x is equal to 0 and y is equal to 1.6. And so now I'm going to plug those into my formula, or my equation for my vertex form equation. So y equals a times x minus h squared plus k. So I know y is 1.6. I know x is 0. I know h is 4. And I know k is 80. So now I want to simplify. So I get 1.6 is equal to a times negative 4 squared plus 80. And then I get 1.6 is equal to a times 16 plus 80. Okay, so now I can't simplify anymore, so now I need to isolate a. I need to get a out by itself. So first I'm going to remove the 80. So I'm going to subtract 80 from both sides to get rid of, right? And so now I have a times 16 is equal to 1.6 all right, so I just grabbed my little calculator there. So I've got 1.6 minus 80 is equal to negative 78.4. Again, I want to get a all by itself, so that means I've got to get rid of this 16. The only way to get rid of 16 is to divide 16 by 16, because then I get 1. Then I need to do the same thing to the other side. So now I have negative 78.4 divided by 16 is equal to negative 4.9. All right, so I'm running out of room here. I'll just put a little line. Actually, I'm going to move this up a little bit. There we go. So I know that y is equal to negative 4.9 times x minus h, which is 4, squared plus k, which is 80. So remember, every equation needs to have the x and the y, because this tells how the height and the time are related. Okay? So now I have my equation, and that's the answer to D. So let's take a look at the last one, which is E. So E says, after how long did the rocket fall into the water, and explain your answer. So if we take a look here, right, the rocket goes up, and then it comes all the way back down, and when the height is 0, that's when it hits the water. So it hits the water after 8 seconds. Okay, so E is 8 seconds. Okay, and that is our x-intercept, or when right, and we're looking at when the height is 0 meters. All right, so just to do a quick recap, right, it's saying what is the maximum height. Whenever it uses the word maximum or minimum, you know you're looking for your vertex, and you know it's going to be the y value of the vertex, so 80 meters. Then it says when. So this is when. When is time. So when does it reach the maximum height? Well, maximum height is the vertex, but the when is the time. So 4 seconds. How high was the rocket above the water when it was set off? Explain. Well, it gets set off when our time is 0. Okay, so that means that we have to look at 0 on the graph, and then we're looking at for the height, so we go up and we see here that when our time is 0, our height is 1.6. So we're going to the y-intercept, so 1.6 meters. Find an equation to describe the flight of the rocket. So here we quickly realized that we had the vertex and another point, so we were good, whereas we didn't have both x-intercepts, so we couldn't do this equation in factored form. So we wrote down the h value, which is the x of the vertex, the k value, which is the y of the vertex. We picked another point. We recognized we could do either of these points, but I picked the y-intercept, so x was 0 and y was 1.6. So I grabbed the vertex form and I just replaced all the letters. So y was 1.6, a 0 minus h was 4 squared plus k, and k was 80. Okay. Then I went ahead to solve it. So I simplified first, did all the math I could. So I did my bed math, I did the math inside the brackets, then I did my exponents. So then I got to this point and there was no more simplifying I could do. So now I needed to get a all by itself. So that means I need to get rid of this 80. So I subtracted it from both sides. Then I ended up with this. Now I need to get rid of the 16. The only way to get rid of it is to divide by 16, because 16 divided by 16 is 1, and that's what I want, 1a. I want a all alone. So I divided both sides by 16, and I ended up with negative 4.9 equals a. So now when I write out my formula, or my equation, don't forget an equation always has y's and x's, because it's telling you how your height, which is y, is related to the time, which is x. So they both have to be in the equation. So it's going to be y equals negative 14 times x minus 4 all squared plus 80. So you're just replacing the a, the h, and the k. Anyway, I hope that helped, tens.